stands for Adaptively Controlled Electric System. It is our in-house project for building a better grid. It is built on the work that we've been doing over the last 5 years. We kind of started with a reactive grid, which most people have. There's a problem and you fix it. Maybe you upgrade it at that time. Over the last couple years, we've been working to be more predictive, plan where we may have problems and kind of make investments in those areas ahead of time. And now we have an adaptive grid. As problems happen, the grid is able to change and adapt to whatever problem that we're having to get people back online as quickly as possible. And in this scenario, it's real-time switching of the grid to bring back people who normally would be out of power instantly back on power to the point where they wouldn't even know they would be in an outage. So it works through a lot of work that we've done throughout the years. At the baseline, you want to really increase the grid that you have and make it as reliable as possible through all the work that our crews do. And then we've worked on this smart computer that interacts with a lot of smart systems that we've been placing throughout the grid throughout the years, working really hard on. And it's able to have a lot of insight to everything that's going on our grid, and it makes decisions based off of the information that it receives. No outage is ever the same as another outage, and now we don't have to predict every type of outage that could possibly happen. We just bring in the information, and through this powerful logic computer, it's able to see what's going on and rapidly get people back online in the most successful way. So before this, and what you'll see traditionally on a lot of electric systems throughout the United States, is there's certain types of outages that can just cause an entire part of town or an entire town to go out of outage. And you have to go address that before you're able to bring anything back online. And then even more so if anything happens on the grid level, so maybe another company has an outage and it forces you to have an outage and there's nothing you can do about it, you just have to wait. With this, we're able to, a lot of times there may still be sections of people that are impacted by an outage. You know, if a pole has been knocked down, there are certain people who can't get back online until you bring that pole up and do some construction. But for a vast majority of people, if you were able to reroute power from another power station that doesn't have any issues, you can bring those people back online, and now we have smart devices in this test pilot of our grid that we're able to instantly reroute power, bringing hundreds or thousands of people back online instantly. So the member will still see a brief interruption of power. A lot of our systems in place allow us to break power for up to 2 seconds and then restore power. 85% of outages that happen in the United States are temporary in nature. Tree branches fallen from a tree and hit the line, and if we just disconnect the line before any energy can build and reconnect 2 seconds later, there's an 85% chance that that tree limb has fallen to the ground or whatever was causing an issue has passed. So they will still see that small break in power, and if it happens to be a permanent outage, something where normally they would stay off, the system is able to detect that and refeed it from a different area. So you may not actually, as a member, know whether that was a blink because of a branch or it was a blink because you have been refed from a different part of the town and now you are not involved in an outage that you normally would be in. So refeeding the grid, the distribution grid looks a lot like the breaker panel in your house. You have a breaker that says kitchen, it goes into your kitchen, serves your receptacles, your lights, your refrigerator, and then you have another breaker that says bedroom, you have another breaker that says hallway, things like that. We have those same things just at a much larger size. So we have a breaker that serves maybe the west part of a town. And that breaker will connect at the end with an open switch to the breaker that would be the south part of town. And we have a number of smart devices up and down those breakers. And depending on where the break in power is, we will sectionalize that part of it. So we will open it on both sides of wherever the problem is, and then we will close in whatever other device to feed it from another one of those breakers. So south part of town can feed the west part of town most of the time, or maybe the whatever outage we had hit multiple places and you can no longer feed it from that way. It'll now feed from the north part of town, and that's kind of where that adaptive comes in. You have multiple ways to solve the problem depending on what in Oklahoma has thrown at us. In the same way that the breakers in your house will open up if something abnormal is going on, that is exactly what happens on the electric grid today. If something abnormal is going on, our breakers do open up. And that's traditionally what has happened. That's why you maybe are in a longer outage. A breaker has opened up because a car has hit a pole. We've had an ice storm, we've had a tornado, we've had any number of reasons why something has happened. Now, that area that's damaged, we can sectionalize it. We can open a breaker on the other end. So a very good example is we had a breaker on the grid open up, drop off an entire part of town. Part of that was involved in our new ACES project, and we just opened the breaker where we connect to the grid and then closed in a breaker to another town, and we instantly refed 1,000 people. So those 1,000 people were able to instantly come back online. So outage numbers for Oklahoma Electric Cooperative are definitely industry leading. We've reduced outages by 60% in the last 6 years and 72% in the last decade, putting us amongst the most reliable utilities in the entire nation. This project, we worked on all of 2021 and got it online in October. And even in that small time, we've been able to save almost 2,000 people from outages and almost 63,000 minutes of outage time. So it's something we're very happy with as a result. It's worked perfectly the entire time. And again, that's 63,000 minutes that people should have been out of power any other year, but now because of this are not. So one of the very interesting enabling things for this technology happens to be OEC fiber. So OEC fiber has brought connectivity to middle of Oklahoma that wasn't there before, and that connectivity is something that we as an electric cooperative have not had before. So we have instant communication with all these devices in the field by utilizing OEC fiber, and that's how we communicate to all of them in 1/1000th of a second to get the necessary up to the minute data to get people back online. So this project is in pilot. You have to test out and prove this technology before you overinvest in it. We were able to utilize a lot of infrastructure that we already had to keep the cost down and the risk low. But even that being said, it protects 10% of the total membership of OEC at this time. So through 2022, we're going to continue monitoring it, making sure it has the impact that we stated that it would. And we have some low-hanging fruit solutions to expand it further, probably increasing its size by about 25%. And then after the end of the year, really look at what this tool does and what the best investments we can make. But the overall goal is that this is another really important tool in our tool bag of reducing outages and increasing reliability to the point that we are the industry leader.